Thank you everyone for joining. Thank you for RSVPing. Today is our first public Pocket community call. I'd like to welcome everyone that is speaking and all our guests. Today we have our CEO, Michael O'Rourke, speaking on ecosystem updates. We have our CTO, Luisi De Leon, and Andrew Nguyen talking about protocol developments as well as tooling that's going to make our mainnet launch more successful. And we also have protocol specialists and advisors from Unstoppable, Nelson Ryan and Dermot O'Ridion. And I am Alberto Hadergy, growth lead of Pocket. So our agenda follows as the Pocket overview, then the Pocket ecosystem, development, incentivized testnet, and then time for a Q&A session. So now I'm going to hand it off to Michael. Thank you.
Great, thanks, Alberto. Super excited to do this. Really excited for the turnout, and so like Alberto said, I'm going to be going over a lot of the stuff from the ecosystem. Real quick, we've got a pretty good showing from the team here, and a whole bunch of people outside of the team as well. So I'm really excited for the turnout so far. So what I'm going to do is go for a quick overview of what Pocket is, and then go into some of the other updates. So for those of you who don't know, Pocket is a protocol that incentivizes people for blockchain. This is done through something called the API layer, where applications building on blockchains need data, and Pocket provides what was previously centralized option, a new decentralized and cheaper option for applications to access data on blockchains. And before Pocket, you would have needed to connect to various different APIs and service providers, or run your own nodes to get data from these blockchains. And since we are using a market-based mechanism through our protocol that we've designed to help coordinate this, this allows Pocket to handle the long tail of blockchains that otherwise would have been very difficult to support for many companies. So, if I wanted to create a Michael chain and said, hey, I want to make a Michael wallet, I can signal to Pocket, hey guys, can you support infrastructure for me? And the market will move in such a way where if it's profitable, then people will support the infrastructure for Michael chain. So that goes with any blockchain. You go ahead, Alberto. So this is a quick overview of how Pocket works. We've tried a big design importance for us is keeping this simple. And frankly, we have a theory or a thesis ourselves where complex systems evolve, and we've tried to make a very strong effort to really make this simple for each independent participant in the network. So to go from the top all the way down, if I'm an application developer and I want to access Pocket, I'll be able to install the Pocket SDK, which will be the JavaScript, Android, and iOS. As we grow, we'll be adding new SDKs over time as well to my application. And all that does is connect me to a bunch of Pocket node providers that are running, let's say, Ethereum and Pocket Core and Bitcoin and POA Network and Tezos, any other blockchain. And all I need to do is say, hey, I need to connect to ETH Mainnet, and what will happen is the Pocket SDK will just route my requests over to the given blockchain. This is done through a data structure that we've designed called a session. There are different names for this in other protocols. Sometimes people call them epochs. Ours is a different delineation from it, but I think architecturally it provides something, a similar metaphor. So these sessions are really important in Pocket because this is what actually wants to work across the protocol. Traditionally, an application will connect to a single API, and they'll say, hey, I want to connect to XYZ API. In Pocket, you don't actually get to choose who you connect to. The protocol randomly selects and rotates in different sets of nodes to provide this work over periods of time through these sessions. And inside the sessions, we've got the traditional block kind of architecture that many of us are familiar with. But fundamentally, these sessions are really an important piece of how Pocket works. And they allow anyone to run a full node, let's say Death or Parity, run Pocket Core next to it, and allow them to participate in the Pocket network. And for me to get included in sessions and do work, I don't have to, outside of the minimum stake needed to be a Pocket or to be a Pocket node, I don't need anything else. So there's no inherent competitive advantage to be seeing more Pocket to be included to do work, which is an important key piece of how it works. So fundamentally through this incentive, our expectation is that given enough demand for a new chain, you've got a bunch of people running Pocket Core nodes alongside all the other blockchains that are running Pocket. So whether that's a wallet, a block explorer, normal applications like a lot of the DeFi applications that we see today, all of that can run on Pocket. So it's something we're really proud of, and it's taken a lot of thought. I mean, to be honest, we've been working on this for 3.5 years, and we are nearing the launch of the protocol, and it's a huge milestone for us, and it's something we're really excited for. So first thing I want to talk about is what our vision is, and the best way I can describe this is I see the crypto ecosystem and landscape kind of evolving as various layers of a stack, kind of like the OSI model from the internet. We kind of see Bitcoin, ETH. We're starting to see Handshake, different protocols like Althea, Whitnet, and they're all kind of taking one specific role in the ecosystem. And Pocket sees itself as another piece of the stack of this decentralized future that we're all building. And we see the opportunity to really be the base layer of full node infrastructure for all of these chains. Because no matter what you're building on one of these chains, you're all gonna need wallets, block explorers, applications. There'll be developers building on all of these chains. They all need infrastructure, and we see Pocket as the common layer to connect all of that, which is something that's really exciting for us. And we're really happy to be getting in at the very beginning of this in terms of explosion of these different chains and tokens that people are launching. So I'm going to go into the ecosystem update and what's new with what's going on lately. And I'm going to.
Sorry, if I can just interrupt you for a second. I think it might be helpful to just clarify two things. So one, just a point that this call is being recorded, and we will be making it available after the call. And the other point we'd like to make is, so yeah, after these introductions, we really do want this to be like an open conversation. So if anyone has any questions, feel free to jump in and ask them.
Perfect. Thank you, Nelson. Much appreciated. Cool. So I'm gonna go over a few things here. One, an update on our node partners infrastructure that's been going on through our testnet. The most recent apps and integrations. I'm going to briefly go over some new products that we're building and launching. I'll let Luis and Andrew get into more detail, but these are things that we're really excited for. And another thing that we're incredibly excited for is the Pocket DAO and Foundation. So I'm going to be giving some updates on that. So Alberto, if you want to go to the next slide for me. Great. So we've had a couple really great developments. One, we launched with DApp node. So you can now run Pocket out of a DApp node through their UI. And this is really important because DApp node is a really critical distribution channel for Pocket, because they, like us, are making the effort to make it as easy as possible for people to run full nodes. And what's great about this is by running, F2, for example, or F1.x, by running a Pocket node next to it, right, you'll be able to further monetize that node that otherwise wasn't being able to be monetized. So DApp node is a really critical infrastructure distribution for us as a protocol. We've had a couple partners really kind of take the lead in really helping us out. I want to give a shout out to Rivet and Skills. Rivet is a wonderful company that that provides infrastructure for Ethereum, and they've done some incredible efficiencies to running specifically Ethereum EVM-based infrastructure. And Skills is going to be really important for us because they are going to help provide staking early on for Pocket. So Pocket, one important thing about Pocket that's different from a lot of recent proof of stake protocols that are coming out is that we're not delegated proof of stake. So which is really important for us. But at the same time, we want to make it as easy as possible for people to be able to participate. So whether that's through your dApp node or through someone like Skills, we expect other people to come on as well to help with this. But just want to give a quick shout out from them. And through our Incentivized Testnet, we've had Simple VC, Figment Networks, and Everstake, and frankly, people from all around the world come participate in our testnet, which we'll give some more solid, I'll give some more solid details on how that's been going in the next couple slides. And I wanted to highlight something called the Pocket Loan Program as well, where we will be lending out Pocket in a limited way to professional infrastructure providers to help provide this the highest quality infrastructure that we possibly can on day one for Pocket. Something we pride ourselves on is that Pocket is permissionless, and we're giving the protocol gives anyone the opportunity to participate. But we also want to make sure that we have the absolute best infrastructure in the world to provide for all of these chains that are going to be coming on in the future. So what are some of the recent apps and integrations we've done? We're in the process of transitioning Saturn Network, a decentralized exchange, fully over to Pocket, which is really exciting for us. They were one of the first, one of the early applications over to switch over to our first version of Pocket, which was Minimum Viable Pocket, that we launched over a year ago. So it's been really incredible to see them come along the ride with us. We submitted a Nifty Wallet pull request, I think last week, and we finished the Icon, Portis, Matic integrations as well, and we're finishing up, wrapping up the Algorand integrations and the woo, and we're also starting to work. We'll be starting to work on the Solana integration as well. And when I say integration, this is specifically on their own SDKs in the case for some of these blockchains. So what happens is a developer using the Algorand or Solana or Icon SDK will be able to easily use Pocket alongside their applications, which gives a very strong incentive for the people who are running Pocket nodes to spin up infrastructure for these chains. So this is just early on what we're doing now, but we expect fully to really ramp this up come June and later in the second half of this year as well. So we've got a couple products coming out that we're super excited for, and we'll have some really nice looking screenshots and stuff that later in the presentation. But something that we're really excited for is these are all running on Pocket. So not only will you be running Ethereum nodes, right, and making money for providing infrastructure for Ethereum, but you can also run a Pocket node and also be earning Pocket by providing infrastructure for our Pocket applications. And everything we release will be running, of course, on Pocket. So we've got a dashboard that's going to provide an overview of the entire protocol. So these are like how many apps are staking, how many nodes are working on Pocket, what are the most popular blockchains. These are the sorts of things you'll be able to see through the dashboard. Through this, you'll be able to purchase Pocket directly through a portal, through our dashboard, which is something we're really excited for. We're going to be launching a block explorer that is really, truly fully decentralized, running on IPFS, using our friends over at Fleek, which is something we're really excited for. And of course, a Pocket wallet that will allow for simple key creation and management. So these are some products that we're super excited for, and we'll be launching in the next month, at the latest. So it's something we're really excited for. And we've done a lot of work when it comes to Pocket being a decentralized network through governance and the Pocket DAO and the foundation. When I say a lot of work, I really mean we've put a lot of thought into this, because we really fundamentally believe that for these chains to really scale, there at least needs to be a framework of how to move forward. Because after a certain point of no return in terms of market cap or size or popularity of a chain, it becomes increasingly more difficult to really make decisions, to be honest. So we put a lot of thought and effort into how we want to design the architecture of the governance of the protocol. So one, we'll be launching version 1.0 of the Constitution that will be released in June. The foundation, and this Constitution, you can think of it like like the rules that the DAO voters and members in the foundation and everyone participating will abide by, right? And these will be able to be challenged through Aragon, for example, Aragon Court, and these sorts of things that we're really excited to be launching. So the foundation is officially created. This is a entity out of the Cayman Islands. They have 3 directors. One of them being myself, one of them being Nelson Ryan, who's on the call, and the other one is Stefan Gosselin, who is based out of San Francisco. And what's really important about this foundation is that because we were able to do this out of the Cayman Islands, in the actual foundation documents, of creation documents of the foundation, it is literally, we are subject to the will of the DAO, meaning the DAO itself can vote and hire and fire any directors they want or supervisors of this foundation. The way we think about this is the world is not ready to interact with DAOs yet. And we need, when I say we as in Pocket Network, we need an interface to interact with the real world, right? In ways that frankly, we're a bit early. So having the foundation be the kind of key point as the interactions with the real world as needed is super important. And something we're really proud of is that in the actual foundation documents, if the DAO puts in a vote saying, hey, XYZ person isn't doing a good job, or we want to add a new person, well then we are bound to do that as created. So it's something we're really excited for. There's 2 ways to join the DAO. One will be a monetary way, right? So you can stake Pocket, and that's separate from staking as a node or an application. Or you can complete a community game path. So it's really important for us to allow anyone to participate in governance for Pocket and to avoid civil resistance, and really inspired from the metagame, if you guys are familiar with that. By frankly doing what you're already doing, that will allow you to have a vote in the Pocket DAO. What a vote actually is management over is over the monetary policy, the treasury, and the on-chain parameters and network upgrades. So if you've dove into our economics, for example, ensuring that the cost is the range of costs for developers is consistent, right? With a liquid token, these sorts of things, the DAO will be voting over, and it's something we're really excited for. And again, it's a permissive system, so anyone can participate. You just have to claim a voting token, and you will be able to vote through the Aragon integration for the Pocket DAO. So, and I see in the chat here, Jacob, yeah. Polkadot as well is coming down the line as well. So thank you for that shout out. Yeah, Alberto, if you want to go to the next slide. Cool. So I'll hand it off to Luis and Andrew. Luis is, just for some context, he's one of the co-founders, as is Andrew. Andrew was the 5th person to join Pocket and has been with us for over 2 years now. And we frankly wouldn't be here without these two. So I'm really happy to hand it off to them.
2 years, yeah, it's crazy. Yeah, guys, hi, I'm Andrew Nguyen. I've been with Pocket a crazy amount of time now. It seems like it was just yesterday, but ultimately, from the inception of this protocol, Luis and I have been working to really make Mike's vision come to life. And I think we've done a nice job of that. So I'm really excited to explain to you guys how we've been releasing, and our latest release, which was release candidate 3.1, 0.3.1 is pre-release, and release candidate 0.4.0, which is upcoming. So in between these two, we also had an internal audit where we had two separate teams. We basically split the blockchain dev between Eduardo and Otto, two of our blockchain developers, and myself and Luis, and we scoured Pocket Core and POS Mint, which is essentially a fork of the Cosmos SDK. And we basically looked through every single file that we could and scoured for any major bugs, code style changes, and ended up with a document, I believe it was like over 20 pages long, of things that we needed to improve on. And we've been executing on, from top to bottom, those issues since the audit concluded. So it's been really an eye-opening and excellent experience from the start. Luis will discuss an update on the dashboard and some extra tooling that's coming out as well that we're super excited about, and some of the bug bounties too. Alberto, you can go to the next slide. Yeah, so let's talk about release candidate number 0.3.1. To date, most stable release, been added some huge features. The biggest of which, you can go to the next slide as well. The biggest of which is the governance module to POS Mint. And just a little background on POS Mint and why we couldn't use the Cosmos SDK out of the box. Ultimately, the Cosmos SDK did not suit our needs in a few different architectural pain points. Not to say that one is better or worse, just ultimately, their Sentry architecture where they have nodes in front of each validator was not quite suitable for our pure proof of stake system. And by pure proof of stake, I mean each node being a validator and a servicer at the same time, as opposed to a delegated proof of stake system. And for us, we just really needed to have our own kind of abstracted version that we could tweak and easily change. And honestly, it's been one of the best monumental decisions we've made to date, in my opinion, separating and allowing us to really have some flexibility. In fact, we recently also forked Tendermint to improve on what we believe is an improvement on the proposal selection algorithm to prevent distributed denial service attacks on the validators themselves, the block producers. With that being said, I won't dive into the weeds too much because that's not exactly about release candidate number 3. We added a governance module to POS Mint, which basically allows what our vision of the DAO and essentially having our delegates vote on certain on-chain issues and able to change parameters and make decisions on behalf of the chain while live and running. And what enabled us to do this really was multi-signature public keys and having them from the transaction transaction builder through the CLI. So what does that mean? It means that when we submit a transaction, we're actually able to have multi-sigs of multi-sigs, which means that each one of our delegates can be a representation of one single part of the governance. So we have this thing called an access control list when it comes to parameters. And each one of these parameters essentially has an owner address, which at maturity will be a multi-sig accounts. And each of these accounts can be owned by X number of public keys, depending on what they want it to be. It could be one, or it could be many. And I believe at launch, we're going to start with just a few, if not just one. And then we're going to build up to make it more decentralized and operate through Aragon as well. And what this allowed us to do by splitting up the public keys was able to have essentially a division of power when it comes to each parameter, because for those of you who are not familiar about the parameters, they're essentially economic knobs and computational knobs that can be turned while the chain is live to allow us to, that affects the protocol directly. For instance, an example of a parameter would be the session node count, the number of signatures allowed in a single transaction. There's a lot of different ones that affect not only the economics, but also our node operators in our applications, like minimum stake, jail time, and the list goes on and on. And if you're interested in seeing the full list of governance parameters, you can see that in our Genesis file by going to one of our nodes, or you can actually see the entire list in our documentation too. In addition to that piece of governance with the access control list dividing each parameter to a single address, we have governance level protocol upgrading, which is a signal that allows the governance to say, hey, we're going to do a major change, which was something that Cosmos SDK did not have out of the box. In fact, when they had to do their last two previous upgrades, they had to get all the validators on the same page. And they, good thing they had a really strong community, because that allowed everyone to upgrade relatively smoothly. I know that their last release didn't go as smooth as possible, but that's how they've been doing it. So our governance actually were able to do that on chain. So that's one of the reasons another reason why we had to kind of fork the Cosmos SDK in that way. And then the ability to have a DAO owner is something else that is in our governance model that's not really seen in a lot of others. So our DAO owner is the person who really owns the treasury and is able to burn and send tokens. Now, I say person, but I really mean account. This can be a multi-signature account. It can be a standard base account, but whoever decides to control it, it's just one single address that's able to distribute that among to whoever submits a proposal or has, or if they need to burn the tokens. Now, keep in mind that every single block that's produced, X% will go to the DAO foundation, or excuse me, the DAO fund, to allow the governance to decide how to distribute those funds. Now, keep in mind, I know what some people may be thinking, one address to control the DAO fund. We actually, because of the way the access control list is designed, we have an address that its only job is to change the addresses for the other parameters. So we actually have an overseer over the other people who can change the parameters. Now, this overseer can't change the parameters himself, but there will certainly be a distribution among a multi-signature for that executive power. And last but not least, just to cover the last bullet point, we have the ability to send and receive from the DAO because the address is a multi-signature. Alberto, you can go to the next slide. So another major update of release candidate 3.0.3.1 was the persistence of evidence in sessions. It really allows us allows Pocket to work as a system. For those of you who are not familiar with evidence, I know Michael briefly went over sessions, but the evidence is essentially, you can think of them as receipts for work completed as the relayers. So if you complete a relay, you may have one piece of evidence for that relay or multiple, or one piece of evidence for multiple relays, right? And what you do with that evidence is you can either, before in release candidate 2, you were storing it in memory and it would ultimately grow unbound. And now you have a configurable limit, and it's not only in cache storage, but it's also in level DB storage as well. And the cache is least recently used, for those of you who are familiar with that. Next slide. And we improved on the dispatch algorithm. The dispatch algorithm changed slightly in the way where we now allow people, let me rewind on that just slightly. One of the biggest problems we were having, or one of the problems we wanted to address in our protocol development as of late, was liveness. Because really it's a very difficult problem to prove if a servicer was down for this amount of time. If he was trying, of course, he'll miss out on his economic incentive, which is, a big pool, but we wanted to go even further than that. We wanted to figure out a way to see if these nodes aren't live, how can we ensure that they get hurt somehow economically and through the protocol. So we already have jailing for missing on consensus. So we wanted to leverage that mechanism and allow it to be to benefit from it from a pocket level as well. So if our nodes are jailed at any time, we want to basically refund the application with new nodes. So for instance, in the current parameters, Pocket has 5 nodes per session. If one of those nodes goes down and gets jailed because they missed X number of blocks, which is also a parameter controlled by governance, as stated in the previous slides, that node is no longer not only eligible for service, but anytime the clients request a dispatch to see who the current nodes are to service them, they will receive a brand new node, which essentially refunds them for all of the relays that they spent on that quote unquote faulty node, even if they had been providing them good service. So this allows us to not only punish the node who had service beforehand by not allowing him to cash in on any of those relays because he was jailed during that session, but it allows us to also have the benefit of our applications receiving essentially a refund or coupon refund for the relays that could have been missed out on, or basically saying, hey, big sorry for the node going down during your session. That was super unfortunate. So the way we accomplish this is we essentially cross-reference the level of which the nodes were at the end of the session and the nodes were at the beginning of the session. And during the session, the quote unquote end of the session variable will just be the latest height, meaning that if we say, okay, this node should be these 5 nodes should be the servicers for your specific application. If one of them is currently jailed, we'll give you a new one and we'll prevent him from cashing in on anything he serviced for you in the future. So something we just have to enforce in order to do that is ensure that the unjailed time is greater than or equal to the session time, and ensure that the jailed for missed blocks is less than the blocks per session. If you have any more questions on that, we can talk about that in the Q&A. Alberto, you can go to the next slide. Right, so I briefly talked about the audit, and that basically wrapped up release candidate number 3. No, we had a bunch of other more granular bug fixes and things like that in our changelog. So you can definitely check that out on GitHub. It's under our documents or docs directory in changelog markdown. But ultimately, I went over a lot of the highlights of the features, at least the ones that I wanted to cover in the short amount of time. So for the internal audit, it basically bridged release candidate number 3 and release candidate number 4. We wanted to ensure that we provided the best product upon mainnet launch, and the best way to do that was, of course, check your own work and have different people look at what you've done as well. So we decided to divide the blockchain team into 2 different parties. Of course, Eduardo and Otto, our blockchain devs, as previously stated, and Luis and I. And between all of us, we ended up with about 75 issues. I believe 11 of those were high priority. Only a few were consensus breaking. And the rest were efficiency improvements. So for things like overhead time on relays, or reading from the database, or improving the caching, etc. So 3 of the biggest ones that we improved on from the audit was we removed the HTTP round trips for queries that is part of the Cosmos architecture. So just to expand on that just a little bit, what that means is when you submit a query through Cosmos currently, you actually have to submit it through you go through Cosmos's RPC. Cosmos routes that through Tendermint and then feeds it back to Cosmos, and Cosmos reads the data and then feeds it through Tendermint back to Cosmos and then finally to you. That's a ton of round trip. We removed that out completely. And if you're more interested in that architecture, we can talk about in the Q&A. Another thing we do, we improved our own selection algorithm by removing the Kademlia-like XOR distance function, and use the same pseudo-random generation algorithm that we use for the Merkle tree indexing. And of course, there's a lot of detail to go there, but I'm just going to skip over that. And if you have any questions, again, please bring them up or ask during the Q&A part. And then finally, we bounded the max amount of chains, which was probably one of the biggest bugs that we that we found in our code to date, which allowed an attacker to essentially stake for an unbounded amount of chains, which would be a ton of compute just using the minimum amount of pocket stake. You can go to the next slide, Alberto. And then now we have our release candidate number 4, upcoming release. Super excited about this one. It's ongoing right now. Next slide. So a few really cool key highlights of this release candidate is we separated the validators by network ID that they staked, meaning that if you stake for Ethereum main, Ethereum Rinkeby, and then Bitcoin, let's say Mainnet, you have essentially your name, your address put in these three different pools. So when we do the dispatching, we don't have to go through each node. We already have that we do the pseudo-random selection, not on the in total validator set, but on the validator separated by your network identifiers. So that's huge efficiency improvement by splitting them up into different buckets through that way. We added a Bloom filter for efficient uniqueness checking for proof objects because we need to ensure that every single relay that goes through Pocket is unique. There's an entropy field to prevent against replay attacks. And instead of looping through every single proof that you have and doing a comparison, we do an optimized Bloom filter, which is, as a lot of people know in the crypto space, a probabilistic data structure that provides very high guarantees. It's used in Ethereum, it's used in a lot of blockchain systems. We updated the fee structure so that's per signature and not per message, because signature, of course, is the highest level of compute for the network in the transaction handling. So now, if you do a multi-signature transaction, it's not a per message fee; it's actually per signature. So I think we also limit that through governance, which is a governance parameter. And then we added a query for node, claims, and claim. And that's just some of the highlights. Again, we have more. I actually may have more. Alberto, can you go to the next slide? No, okay. So yeah, we have more on our changelog, but we can, if you're more interested, we can, again, talk about the QA, or you can read the changelog yourself. So this week, we are performing load tests. Luis is taking the lead on that. We are doing essentially pushing our network to its limits through max validators, which is more of a Tendermint kind of bottleneck, but we want to see how far we can push this BFT algorithm. And then we have max relays, which is essentially how many relays can one node hold. And we have relay time, how quickly can we get these relays executed in parallel. We have normal distribution of the relays among all the nodes, normal distribution among of node selection among sessions, normal distribution of proof indexing for pseudo-random selection of the Merkle tree. So a lot of really exciting and super important load tests that I'm really excited to see the results of. So with that, I believe I'm going to hand it off to Luis. Alberto, you can get the next slide just in case. Yeah, so this is Luis's portion. Guys, thank you for your time. And again, if you have any questions, please ask me at the end.
Perfect. Thank you, Andrew. Sorry. Thank you, Andrew, for that. So I'm gonna be talking about some of the products that we're gonna be launching first on Testnet to give a chance to the community to take a look before the mainnet release. But these products are aimed to be utilities that every Pocket user is gonna be able to use and ease the UX of using our decentralized network. These tools are, in no particular order, the Pocket wallet, which is completely decentralized and backendless, is going to be deployed on Fleek. We got the Pocket Explorer, which is our block explorer, which also is going to be completely decentralized, backendless, and we believe it's first of its kind, and it's also going to be deployed on Fleek. What this means is that these are pure client-side applications, and they establish a connection directly to nodes in the Pocket network. And from their own, the client in the user's browser is connecting directly to the blockchains without going through any central backend infrastructure. The next one is the Pocket Dashboard, which is an abstraction of our very comprehensive CLI, where users are going to be able to register their nodes and their apps into into the network, as well as manage them. They can unstake, they can unjail them in case nodes get jailed, for example, without even having to use the CLI. They're gonna be able to import their accounts, but it's totally non-custodial, meaning we won't be keeping any user's private keys in our servers or whatnot. People are gonna add their private key when they need to sign anything. The next part is it's embedded inside the dashboard, and it's the Pocket Gateway. It's a centralized gateway that provides the convenience of Infura when building applications, so you don't necessarily have to use any additional tooling for your app, but it has the decentralization factor that every request going to that central gateway ends up in a Pocket node. So what that means is that even though you're gonna be sending requests to the gateway, which is gonna be under a single centralized API, that gateway is gonna programmatically use your own account to submit these relays to the Pocket network, where they are actually gonna be serviced, allowing this gateway to scale and be multi-chain from day one very, very easily. So the first preview that I want to give you, and one shout out that I want to make, it's shout out to Valeria, who is our lead designer, who designed all the UIs that you're gonna see in all of these previews. She's the one keeping Pocket pretty at all times. So this is a preview of the wallet. So it's gonna be a very, very simple wallet. It's all client side, as I mentioned. You're gonna be able to import your account, and while you're in a session logged in, you're gonna be able to use that account, but if you, for example, refresh or something, you're gonna have to re-add it because it's totally non-custodial on client side. You're gonna be able to see if your account is a node or an app, and you're gonna be able to send transactions, basically transfer Pocket between other accounts through this wall. The next step is the Block Explorer. So the Block Explorer is really curious. We have codenamed it Leaf because of Leif Erikson, who was a famous Nordic explorer. And the idea with the Block Explorer is that the Pocket flavor of it, it's gonna connect to the Pocket mainnets and testnet, but it serves as a framework that allows that allows the exploration of any blockchain given the right configuration. It's gonna be totally open source, so if any other blockchain project wants to go out and wants to have an out-of-the-box, a completely decentralized client-side block explorer, they're gonna be able to do that with. So the next one is the Pocket dashboard. So the Pocket dashboard, this a preview render, of course. It's gonna be our abstraction of the CLI, which is gonna allow apps and node operators to go in and register their apps through the interface instead of having to download a CLI and whatnot, which is a lot more convenient. The dashboard is also gonna display some general networking. So this is the gateway. So the gateway is gonna be, the UI of the gateway is gonna be inside the dashboard, and it's gonna be available to apps only. When you create your app and you stake POKT, one of the ways that you're gonna be able to consume your bandwidth is gonna be through the gateway. And as you can see, this is a settings page, pretty similar to what you will have in centralized providers, where you get a gateway key, a project secret, and an endpoint. And what this will allow you to do, if you see that drop down right next to the endpoint, that's gonna allow you to circle through the different chains that you staked for. So the gateway is only gonna allow you to do the amount of relays that you staked for in order to, because that's the way the gateway can execute the relays to the Pocket network. So it's going to bring a very, very similar experience. And one key thing of the gateway is that you can use it as a drop-in replacement by switching out the URL with the gateway URL without having to necessarily install the SDK. We see this as a transitional option where some apps might want to experience the power of Pocket since day one, or we maybe haven't come to the particular blockchain that they are wanting to build for. And this is one of the another option that, even though it sacrifices some decentralization factor, it adds a convenience factor on top of it. And that's it, guys. Like that was a preview of the 4 upcoming new products that we're gonna be, as I said, first releasing on Testnet, and afterwards we're gonna be releasing them on Mainnet alongside our Mainnet release. So I'm gonna hand it off back to Mike, who is gonna be doing an incentivized testnet update.
Cool, thank you. Yeah, and we're running up on the hour. I'm okay going as far as 1:30 our time if we need to answer some of the questions, because we did get some really great questions from our Discord. So Alberto, you want to go to the next slide real fast? Great. So this is what has been going on in Testnet, and as an initial or for some context, when we first did our first load test, we had it froze the network immediately. So the fact that we've been able to improve everything iteratively, and as we've caught all the bugs for building a brand new system, we're super excited to be scaling this up in the next 4 weeks. But we've had people from all around the world come participate running nodes. The initial load tests were at 150,000 requests an hour, which results in several million requests a day. And we plan to increase this to millions of requests an hour over the next 4 weeks, particularly as Andrew went over with RC 0.3 and RC 0.4. We're super excited. So there's a big difference between, or the differences between the public test, load tests that we had and the most recent internal tests are quite massive. And we are incredibly excited to be able to reach a 99.8% success rate, because this means we are well on par with current centralized infrastructure providers, but we're able to offer Pocket at a fraction of cost. So and with a truly decentralized network. So it's something that we are incredibly proud of and excited to continue improving. So definitely keep an eye out over the next few weeks. We're going to be running some more load tests, and really excited to see the results. So yeah, let's hop into Q&A. We had a couple questions early on, and then we had some great conversation going on from our Discord. The first question, it's a very common question that we get in terms of the difference between Pocket and the graph. For those of you who don't know, the graph takes care of the indexing layer for Ethereum applications. And what's interesting about that is we see ourselves as a kind of like a level below that. So where you have these caches and indexes that many of these Ethereum applications need. For example, a lot of the DeFi applications that you see that have very extensive smart contracts that require quick data, but have to kind of query all this data in a short amount of time. The graph does an amazing job at fixing this. What's interesting though is that all these caches and indexes, they need full nodes to see them. So I think there's actually a really interesting collaboration between us that can happen, where you can actually run a graph node serving some DeFi application while having it potentially being seeded by Pocket. So to lead into that, we're solving different problems in the sense where we are really focused on incentivizing full nodes as kind of a primitive, whereas the graph is really focused on this indexing layer just above the nodes, effectively. Luis or Andrew, I don't know if you guys wanted to add to that. That's kind of my take on it.
I just want to add a very brief point that the way Pocket was designed from the ground up, we're trying to incentivize infrastructure, whereas the graph started from another layer, which was the caching and indexing of Ethereum-specific data. So there's definitely synergies between the two, more than maybe actual direct competition. Now the graph did launch its own incentive model, but again, because of the principle thinking behind the inception of the two projects, the way I see it particularly, it's more of a synergy than an actual direct competition.
Yeah, not to mention Ethereum.
Sorry, go ahead, Andrew. Didn't mean to interrupt.
No, sorry. Yeah, not to mention it's Ethereum only. So.
Yeah. Yeah. So that's kind of the big differences. So the other question is, how can Pocket solve the Oracle problem? This is something we're really excited for. We've seen things like Chainlink and these other protocols start to get some traction, and we think there are some potential issues with them, particularly with actual verifying data that's being and having the nodes that are skin in the game actually getting slashed for providing bad data. So if you think about kind of Pocket's architecture, the entire system is built in a way to provide data trustlessly through a network of nodes. So it wouldn't be that far of a stretch to be able to say, hey, let me get this price on an exchange, or maybe an API from different sporting applications like ESPN, NBA, CBS, and be able to input this information or to verify that this information is correct, right? Because what's important about Pocket is if you're querying 5 nodes and 4 respond with an answer of 20, and the 5th one responds with an answer of 15, meaning they're lying, they can get challenged and slashed by the protocol. So really, as Pocket is architected, it is naturally solving this Oracle issue. Andrew, Luis, I don't know if you guys wanted to add to that.
There's something to be said about the directionality of data in terms of how Pocket can solve the Oracle issue versus other platforms like Chainlink, for example. So Chainlink tries to go from the blockchain out, and Pocket goes from outside in. So there are very, very interesting things because Pocket can be chain agnostic because of the directionality of the data from the get-go versus having to deploy on each of the individual platforms in order to go out to get data and feed it to these smart contracts. So in the end, it's going to be mostly about what the Oracle need is, and applications can get very, very specific and creative with that. Now that Pocket provides a solution for one direction of the problem versus other platforms.
Great, thank you, Luis. And Jacob asked, I suppose in parallel to Chainlink, we're the Pocket Marines. Yeah, hopefully we're building it now, right? We're kind of building our movement now, so we're super excited to be early on in building it. So yeah, and so this was a question we got in Discord asking about Pocket's incentive structure and who pays for Pocket. This is something we're really excited and proud of in terms of how Pocket's economics are designed. So in Pocket, we have one single cryptocurrency that is potentially volatile. What's different about us is that we don't have an arbitrary block reward. So when a relay gets created and validated by the network, a node can then claim that work that they did by submitting effectively a proof of work, but it's just a very different proof of work than Bitcoin's proof of work, which I think this goes into a little bit of this next question in terms of how do range proofs enable the proof of data transfer. So before we dive into kind of like actually how do these proofs work, in terms of who pays for Pocket, so Pocket isn't free. Like you would for a traditional service, using AWS or something like that. You'll pay a monthly fee to access some set of throughput or some amount of data or something like that. Pocket's different in the sense where instead of paying a monthly fee, you stake a certain amount of Pocket ahead of time to lock in some price, and that price may be volatile over time. But once you stake, and that's a key important piece of Pocket staking, once you've staked once, that locks everything in. And the important part here is using truly crypto native incentives to really bootstrap the ecosystem, the market, and the incentives that go along with this. Because what's really interesting about Pocket as well is about our economics is that early developers, early participants, if you're an early developer coming in and you need, say 100,000 API requests a day, depending on how we do attraction and nodes coming in and developers coming on as well, that Pocket may be able to purchase more relays with the same amount that you previously had staked. So we've kind of put in these native incentives to really bootstrap the protocol and really have a truly crypto native solution that we think is significantly cheaper over the long run than what kind of traditional entities might be able to offer. So so our block rewards are completely based on usage. So as soon as someone does some work, they then claim it, which I'll let Andrew dive into now. But effectively, when I claim my work, that is Pocket's block reward. That is divided amongst 3 different participants. One is the actual node who did the work. They get 89% of the reward of that full Pocket reward on a per relay basis. 1% goes to the block producer that was chosen through Pocket's proof of stake algorithm, and 10% goes to the Pocket DAO, and that is specifically to help solve the tragedy of commons issue when it comes to protocol development over the long run. So with that, I'll toss it over to Andrew, who will be able to give a much more clear explanation than I will in terms of how do the actual proofs work in Pocket, and how do you actually claim that I did 1 million relays versus 1,000, and how can I how do we ensure that I didn't lie about that? If you don't mind going over that, Andrew.
Absolutely, yeah. I think that I'll go as low level as I think I need to. If you guys want me to go more low, please tell me, and I'll definitely go lower. But you can think about it like I mentioned earlier in my portion of the talk that every Pocket node will store the relay in these evidence objects, essentially a receipt for that relay or multiple receipts for those relays in a single evidence object, right? And then what you do with that evidence object when it's time to prove your data, which is set by governance, but right now I believe it's as soon as your session's over, you need to create a claim, which is you're claiming that you did this much work. And inside that claim object, you will provide a Merkle root, which you take all of your receipts from a single evidence object for that session, generate a Merkle tree that's a specific data structure called a Merkle sum index tree. And the Merkle sum index tree is essentially a sorted Merkle tree sorted by the sums. The sums being the numerical value of the hashes of the leaf values. And that's as low as I'll go for now. If you want me to go lower, I absolutely can. So we have this sorted value of receipts for these relays completed. We generate the root for it and we say, okay, I completed this many relays. And remember that each individual relay is signed by a client, and the relay proof contains an application authentication token for that client, which contains a signature for each application. And each proof also contains who the servicer was inside of it, so you know that it's for this specific node. Now, what you do when you submit that claim is you say, I did 1,000, relays for this application. Here is the Merkle root for all of those, and essentially that claim will get verified by all of the validators on the network, which should be every single node at this point. And what they do is they store that claim. Now, these claims, they're not very big. We're talking about anywhere from, depending on how many you do, 200 to 400 bytes the first initial message. Because all it is a Merkle root, how many you did, and just some other meta information that's needed to verify that you are the person who did these. Now, a couple sessions later, and the reason we have some of that space is because we want to prevent essentially a trick attack where you can convince the clients that the session is ongoing. We reveal a pseudo-random generated secret that everyone can agree upon using the block hash data. And this secret will reveal which index out of the total number of relays that you've completed you need to submit, which makes it a zero knowledge range proof, because we select from a range a single value of the a single value throughout all of the proofs, and we essentially are going to validate that value. Now, how can we prove that that single value was within the tree, and how can we prove that single value was completed beforehand? Well, because we have the spaces, because of the way the Merkle trees work is we hash upward, we know that order is locked in. And when we do the verification, we actually make them submit the leaf node and the cousin to the leaf. And what we do with each of these, the cousin's really there to prevent replay attacks, to ensure that they can't just submit the same exact relay throughout the entire leaves and create a tree from that. But what we essentially do is we take the Merkle proof, we take the leaf, and we hash our way upwards until we get to the root. And that will verifiably prove that this leaf is of the tree that was generated beforehand. And it's important that they generated the tree beforehand so that they can't just change the order and say, oh, this is the index that you selected. So for instance, if we selected, let's say the protocol selected relay number 1 out of 1,000, that's the one you have to submit in order to prove that you did all 1,000 relays. Because it's probabilistic that if you were able to do this one relay, you have done all of them because you didn't know which one would be selected. So you submit relay number 1, we verify with its cousin, which would be relay number 3, and then we hash our way upwards based on the Merkle proofs that you submit in this proof transaction. And these proof transactions will be larger. We currently benchmarked one around a kilobyte for, I believe, 10. Don't quote me on that. I'm not going to even say that number, but it was quite a large amount of relays. What the verifiers are able to do is essentially determine that this proof was of that tree, and then they verify the leaf itself, the leaf and the cousins themselves, by saying, okay, the signatures are true for this client in this application, and that you have now successfully proved in a zero knowledge way that you have done all of these relays for a probabilistic chance. And then we reward them after the fact. So that's essentially the whole life cycle. I don't know if that was too deep or not deep enough, but I think that covers pretty much all of it.
Thank you, Andrew. Yeah, and we'll be releasing documentation explaining all of this in the coming weeks as well. So it's something that's really, truly novel about what we've built, and it's a true proof of work, or useful proof of work in this respect, as opposed to spending electricity on Bitcoin. So it's something we're really, really proud of. And the last question here is will Pocket support Eth 2.0? That's a definite yes. I actually find that Pocket becomes more useful with sharded blockchains, particularly as data becomes siloed between these chains. It's a really interesting problem that Pocket, I think, is perfectly suited for. Because if you have a chain with a bunch of nodes or a bunch of different shards, you'll need to request data from each one of those shards, and routing that through Pocket is quite frankly trivial. So absolutely.
Mike, before we leave, just to chime in on the sharded networks. So any sharded network can actually be supported in Pocket because of the way we identify networks. So we don't identify networks just by the protocol they use, like for example, Ethereum. We identify networks by a series of filters that then we use to produce a hash. And these hashes are arbitrary, and they can go, by launch, we're gonna limit it to 65,000 networks initially, but these can actually grow over time with a protocol upgrade, of course. And what we can do is that we can make each individual shard of a network be its own network within Pocket. So for example, Ethereum Mainnet Shard 1, Ethereum Mainnet Shard 2, Ethereum Mainnet Shard 3 will be represented as different chains that apps can stake for. And what that allows us to do is to properly route to nodes that are supporting specifically those shards.
Yeah, thank you. Yeah, so great. I believe that's everything we had. Was there a last slide, Alberto?
Yes, there is. But I also want to take this opportunity to see if anyone else has any questions that weren't answered throughout the presentation. So feel free to unmute and ask away.
Hi, will be incentivized testnet extended? Or is it done already, or what's the state?
Hey, I can jump in here real quick. This is Patrick, by the way. Yeah, so the current version of incentivized testnet runs until the release of Mainnet. So all the incentives that you see outlined in that collateral stand as is. But what we're doing after that, Mike alluded to it, is kind of an expansion of the incentivized testnet by overlaying like constant incentives through this quote unquote gamification mechanism. So there will be opportunity after this initial incentivized testnet to continue to participate and earn rewards from it in many different ways.
Yeah, great, because unfortunately the POC was still quite under the radar. So a lot of people and my friends and other partners project didn't know about POC early, or didn't have a chance to participate on there, and they're like starting to look around just right now.
Yeah, yeah, thanks for that. Yeah, you're totally right. We were definitely heads down, flying under the radar. So yeah, exactly that. There's going to continue to be incentives, and also like we can form kind of direct relationships with individuals and work out something on a case by case basis as well. But as far as like extending incentivized testnet, that's definitely going to happen, and it's actually going to be expanded into other avenues as well, like Mike alluded to, like governance, community, apps, and nodes specifically.
One could compare it to maybe Bitcoin as a fair mine, or as the same way Bitcoin gets compared with that. So once we're live, it's live, and anyone can participate as well. So there's that as well. Yeah, we've been moving really fast, and really excited to get to mainnet. So thanks for that question, Jacob. Were there any other questions that anyone wanted to bring up?
No questions. Just wanted to say great work all around. This is Shahan. Nice to meet everybody.
Cool. Thank you, Shahan.
Thanks, Shahan.
Great. You wanna go to the next slide then, Alberta? Cool. There you go. Speaking of incentivized testnet, it's not too late. So definitely come on, run a node. The way we've designed it is you get the max amount for that first month. Everyone does for participating. So that first month you get I believe it's 15,000 pocket for participating right away. So it's still not too late either way. And yeah,
so going to spread the word and be the first POC Marine.
Yes. Yeah, we need we need some we need to get them our meme. We need to up our meme game, I think. So maybe we'll start working on that too. Well, thanks everyone. This has been really, really awesome, and frankly, like I'm incredibly happy with the amount of people who came, and thank you for the support. And we definitely look forward to us doing this more often, and generally just really excited to do this. So really looking forward to these announcements, really looking forward to these products that will really open things up, and really looking forward to our Mainnet announcement coming up in the coming weeks as well. So yeah, thank you for joining, and thank you for coming. I'm happy to continue the conversation on Discord as well. We had some really incredible questions that we couldn't get to that were asked on there that, you know, I had some great conversations. So happy to you know, if you have any questions for Andrew or Luis or anyone else in the team, you want to really dive into the nuts and bolts of Pocket, you know, it's yeah, we're happy to be there for you. So thanks for coming.
Awesome.
Thanks,
Thanks
Mike.
everyone.
Thanks, all. Great work.
Everyone. Thanks,
Thank you,
everyone.
everybody.
Thanks, everyone.